Hi Ashwin. Hi Ashwin. How are you doing in school? What are you doing in school, Ashwin?
Hi, Auntie. I think in school we're doing right now, I think we're doing, we just did exponential growth and decay. Like
Okay. Have you started polynomials?
in school, I don't think so. No.
How are you doing? Doing good?
Yeah.
Okay. One second. Wait. I think all of them forgot. What is going on? One second, Amma. Okay, Ashwin. So we'll wait for another minute or two. Ashwin, you can go ahead and ask any questions that you have, Ashwin. Why waste time? We can go ahead. You go ahead. You logged in on time, right? Go ahead.
I don't think I really have much questions as of now, Auntie.
Not from the book.
Hmm?
Not anything from the book.
No.
Okay. Okay. Quadratic factoring and all, if you really work on the book, you'll have a lot of problems.
Hmm.
Quadratic factoring and all, if you can, whenever you have time, if you go through the book, you'll have a lot of questions.
Okay.
Okay. Yeah, Dia. How are you, Dia? What are you doing in school, ma'am?
I'm good. Um, we're not really doing much right now because there's telepass testing going on, so the teachers aren't really supposed to teach us much.
Mm-hmm. So what do you get to do?
It's mostly just free time, and there was a few days before that,
Okay.
like before telepass testing started, that my teacher was gone, so she's just like going over what we were supposed to learn during then.
Okay. Okay. 1 second. Let me remind the others, guys. Okay, guys, let's move on. Okay, I wanted to review some of those and go to polynomials actually. Let's see. You're able to see my. Okay. Have you discussed polynomials at school, Madhya?
Yeah.
Okay, so you have done some polynomials at school, which is good. So what I plan to do is I plan to go exponential growth decay. Have you done word problems in exponential growth decay? Let's see.
No.
You would have. Have you done exponential function in school, ma?
A little bit.
Okay, let's see. You're able to see my board, huh? Yeah, you're able to. Okay, let's see. Let's review those word problems. I want to go to polynomials, addition, subtraction, multiplication, division. I could not go over it very fully, but we did something. Okay, so let's see this one. Um, I remember doing one exponential function with you all. Let's see. Okay, how about this? Let's see this one, guys. I don't want it to be too hard on you, but at the same time, let's see. Um, okay, let's see this one. How will you do this one? How about this one? You're able to see my board. Okay, we will review the exponential functions in depth and then we'll do. A culture grows according to this formula where t is in hours. After 4 hours, the population will be equal to 2430. Another culture starts with twice the initial population of the first but grows at the rate of 4 by 3t. What time t will the t population be equal? You want to try on your own or do you want me to do it? Let me know, guys. I just want to know where you are. Go ahead and tell me. I Yeah, this is a challenge problem. Do you want me to try or you want to construct the equations, guys? Anish,
Yeah,
you tell me. Anish, Diya, Ashwin, you have to tell me.
I'm kind of confused about this, auntie.
yeah, what he said.
What is the cause of confusion? What is the cause
I'm
of
just not
confusion?
understanding. I'm just not understanding how this problem is like how this problem works.
Okay, you don't understand, you're saying. So, why don't you solve only this, first of all?
Okay.
Can we first solve that? That's easy, right? A culture grows according to the T is in hours. After 4 hours, the population equals 2430. That should be solvable, right?
So like what's the first what's the initial population?
What is the only unknown?
Um T.
T, yeah. T is
Yeah,
given, right?
yeah, V.
P of 0. Good job. P of 0. Good job. So find out P0, the initial population. From that, you can continue with the next one. You're going to do it. If you don't know, I'll do it. What are we finding, ma? What is P of 0? Who can tell me the P of 0? Please send the answer in chat, guys. I really want to go to polynomials though. Done? Did you get it, guys? Guys, where are we, ma? You should have gotten P0 by now. What is P0?
I got 480 in T.
What is it?
I got
480.
480.
Go ahead with the next one. That's right. Go ahead with the next one. What do you do next? I really should want you to be able to do this. You got 480, right? Right? Anish,
Yeah.
what did you get?
I don't know how you do it.
Huh? Anish, you have to be loud, Anish. Huh?
I don't know how
Anish,
to.
I have no idea of what you're saying, Anish.
I don't know how to do that one.
Why? Okay, so P of t will be equal to P0. This is the initial population. Clearly, it's given after 4 hours. It's just plugging in values, right? After 4 hours, this is the value. So 2430 will be equal to P0 3 by 2 power 4, right? Now P0 will be equal to 2430 divided by, this is just a calculator entry. Type it in the calculator and find out the value as 480. Now, after finding the initial population is 480, another culture starts with twice the initial population. What is 2 times 480? Will be equal to
960.
960. Good job. But so the second culture, we are working on the second culture now, right? So what does it say? P of t will be equal to P0 4 by 3 power t. Now the initial population we have for this one. So they are asking when at what time t will the two population be equal? So what do we do for that? We have to make them equal, right? So basically this is 960, right? 960 4 by 3 power t is the population of the second culture at any time. What is the population of the first culture at any time? It started with 480 3 by 2 power t, right?
Mm-hmm.
Now, how are we going to solve this? How would we solve this? Okay, how would we solve this? Now, divide by 480 on both sides. Divide by 480 on both sides. What happens, guys? What happens? 2 4 by 3 power t. Let me erase this side and keep going. Ashwin, Diya, Anish, are you able to follow?
Yeah.
Yeah.
Okay, now 2 4 by 3 power t will be equal to 3 by 2 power t. Now how to solve this, guys? There is an exponent t, right? Can we bring it together somehow? Can we combine the powers somehow? Do you think you can combine the powers? Let's see this one. 2 square by 3 whole power t will be equal to 3 by 2 power t. Now, is there a way to combine them? Is there a way to combine them? Mm-hmm. Let's see. Guys, are you able to proceed with this, or you want me to do this on the board? Shall I show you how to do this? Yes, no, I need to understand. Ashwin, do you know how to proceed? Diya, do you know how to proceed with this?
I think so.
Ashwin, do you know?
I'm pretty sure, yeah.
How about you, Anish?
Maybe.
Okay, try then. So 2 power of 2t divide by 3 power of t. So I'm going to divide that. See, basically, if you divide, okay, divide both. See, this will be equal to 3 power of t by 2 power of t, right? Now we have everything in its place, right? So what am I going to do? 2. So divide. Okay, basically you multiply by 3 power of t on both sides, right? Now what do you do?
Divide.
Divide by 2 power of 2t maybe?
Yeah, divide by 2.
Uh-huh. Now what happens? Now what uh-huh. So divide by 2 power of t here, 2 power of 2t, right? So this goes out. Now 2 will be equal to 3 power of what? T plus t, right? Same base. Here the same base. 2 power of 3t. Does that make sense, guys?
Yeah.
Now can I go ahead and say what is 3 square? 3 times 3, 9, right? 9 power of t by 8 power of t, right? I can say 2 will be equal to 9 by 8 power t. But how are we going to solve this one? How are we going to solve that one? 2 equal to 9 by 8 power t. How are we going to solve that? Do you know how to solve that? We did one of the problem in class using the calculator. Do you remember? Do you remember?
I can do it with the calculator.
Do you remember how to do it in the calculator?
Yeah, I can do it with the calculator.
Good. Okay, go ahead and find out what is the answer. Quick, come on. We can move on. I want to do one more problem. I'm not convinced, guys. Go ahead. What is the answer for that one then? Go ahead, guys. What's the answer, guys? What is the answer, Ashwin?
I don't know. It says I got like 5.884, and then like, so basically it says I got 6.
Basically,
Like if I round it.
what did you get, Dia?
I got around 6 hours.
How about what did you get, Anish?
Yeah, I also got in 6 hours.
Yes, 5.88 is correct. So this is how you get to solve this. Good job. 6 is correct. Okay, let's go ahead and try the second one. After this, I'm going to move on, guys. Okay, let's see. How about this one? We'll do a growth decay problem. This was also a growth decay, right? Basically, it was a growth problem. Okay, let's see. How about this one? An investment grows at 8% annually. After 5 years, it would be worth this. After 5 years, you have the amount given, right? Another account. Oh my god, what did I do? Wait, guys, I made a mess. Okay, after 5 years, it is worth 14,693. First of all, can we go ahead and write the equation for this one?
It's compound interest, right?
What am I?
It's compound interest, right?
Yes, compound interest.
Mm.
So what do you do on that? What do you know how to write out the growth and decay? Do you know how to write out the growth and decay function? F-O. Would you be able to write the growth and decay function? We did this last class. Okay, so y will be equal to a, which is the initial one, plus 1 plus r power t. This is growth. Okay, a is the initial population, r is the rate at which it grows. Whereas for decay, what will you do? Y will be equal to a times 1 minus r power t. So a is your initial value, right? This one is the rate at which it grows. This is the time taken, right? This is the final value. Okay, why it is 1 plus? It's like 100% plus. It grows at 8% annually, means 108%, right? So here it is 108% is what? 108 divided by 100, right? That's why we say this is 100 by 100, right? Plus the rate we are saying. So it grows at that rate. Now go ahead and calculate. Okay, when I read this problem, an investment grows at the rate of 8% annually. After 5 years, it's worth. So, after 5 years, the value is given. They have not given the initial value. Can you go ahead and find the initial value first? Go ahead and find the initial value first, and then for the second account it decreases 6% annually, means you will go with this, okay, decay, but our value is given, so we need to understand a value for this one, how much must be invested in the second account. Okay, so we don't know the a value, but they're saying after 5 years both accounts have equal value, so t will be equal to 5. So when t equal to 5, you have to equate both the value that will be remaining at the end of 5 years in both of this. Can we try this one, guys? You're going to try and tell me the values. It's not a hard one if you know how to solve. I want each of you to message. What is the question though? Oh, how much value should be invested in both the accounts? Okay. Anish, where are we, Anish? I'm not getting a hang of what's going.
You're live. Recording.
Anish, where are we? Are you able to substitute and do?
Huh? Yeah.
Anish, you have to be loud and clear, Anish. I have no idea what you're doing. Just let me know.
So I have to do y is 5. Oh God. Y is 5. Huh?
Dia, did you get the answer?
Almost.
Done, guys? Ashwin, what is the answer, Amma? Guys, this question cannot take this much time. What did you guys get? Okay, what is that you're stuck on? Ashwin, what are you stuck on?
I'm almost done at the I'm in like the last.
Dia, how did you get it, ma'am? From where did you get this? Dia, what is the first equation you framed? Yeah, I'm really afraid to go further, guys. If I, yeah, go ahead.
I did the growth formula.
Okay, what is it? How did you substitute? Quickly go ahead and explain.
14,693
Yeah.
equals
Okay.
A times 1.08 to the power of 5.
Correct. So what is A?
And then I got 10,000.
Okay. And then?
And then for the second account, I did 14,693 equals to 1.06 to the power of 5.
1 point?
06.
Did you see this?
I thought it was like 0.06.
Did you see this? Did you see this? Yeah, 0.06 is the rate, but then it decreases. Did you see it? Decreases means what you should do. You cannot add, right? 1 minus r, right?
Subtract?
0.94 to the power of t, right? After 5 years, right?
Okay.
So now what happens? How do you find out A? How do you find out A?
I don't have that calculator website.
You can do it in Google and check TA84 calc. If you put it, automatically it will come. TA84calc.com. So what is the answer, Dia? Did you get this? Looks like you didn't, right? Dia, go ahead and tell me the answer. Or Ashwin, go ahead and tell me the answer.
I got about like $20,000 and $20.41.
14,693 divided by 0.94 power 5, right, guys? Okay. 14,693 divided by 0.94. 14,693. Wait, let me check. 693 divided by 0.94 power 5. Okay. What was the Ashwin, tell me the answer once more. 20 point.
I got 20,020.41.
Which makes sense. Good job. Good job. Around 20,000. Makes sense. Can I move on?
Yeah.
Okay. Do you want to do 1 or 2 more problems, or I can move on? See, I have to go to polynomials though. Okay, let's go to polynomials. Maybe I'll give you a separate homework on growth and decay is what I honestly feel from here. Okay, let's see. Now I'm going to stop this. I'll share it with you. Okay, so now let's go to this one. Okay, let's get started with polynomials. Do you all know what a monomial is? What a monomial is?
No.
Product of a number, product of numbers and variables. Product of numbers and variables. It has restrictions, okay? I did not tell you about the restrictions, like 4x, 4x, y, 4x square y, 4t square y, x, anything like product of numbers and variables. Product of numbers and variable here is x power of 0. Here the constant term is 1. Here the constant term is 1. Here, do you see these are called monomials? What is a monomial? The product of numbers and variables in such a way that the exponent on the variable is a whole number. Here the restriction is exponent on the whole number on the variable is a whole number. Make sense, guys? What is a whole number? Starts with what number? Exponent on the variable is a whole number means it starts with what? Starts with what, guys? Which number? Anish, if it is a whole number, the exponent starts with what?
It starts with a whole number.
Yeah. So whole number means what?
It's
What
a
is
monomial. Cause like 4 times 4.
Diya? Exponent starts with a whole number means what, ma'am? Exponent has to be a whole number means what? Exponent on the variable has to be a whole number means what? Diya, that was a question to you. Ashwin, do you know what a whole number is?
Yeah, auntie.
What is it?
So if the exponent of a variable is a whole number, it's just like,
Uh-huh.
or
What
I
does
guess
it
like
mean?
for example,
Go ahead.
I mean, number will be a whole number. It won't be like a fraction.
Yeah, what is a whole number, ma?
Like
What it
1,
means
2.
to take 1, 2, but is 0 included?
Yeah,
Yes, 0 is included. It can be any number from 0, 1, 2, 3, 4, 5, right? And so on.
yeah,
Okay. Now, is this a monomial? Is this
Yes.
a monomial? Okay,
yeah,
how about this? How about this? Square root of 4 x power of 5, is this a whole number?
Yes.
Yes.
yeah.
Okay, it has to be product of numbers, variables. Variable exponent should be a whole number. That's all. How about this 1 by x? Is this a monomial?
No.
Mm,
No.
No,
Why? Because
It has
the,
difference.
the exponent
not a
of
whole.
x would be a
Yeah,
negative number, which is not a whole number. How about this 4x power of 1 by 2? Is it a monomial or not?
Yeah.
What do you think, Ashwin?
uh,
Hmm?
I don't think.
No, it is not, because yes, it is a product of, it is the product of number and variables, but the exponent of the variable is a rational exponent. This is rational, not a whole number, right? Similarly, how about this? Is this a monomial?
No.
No, why?
Because it's not like resulting in a whole number. It has rational exponent.
Exactly, the exponent of the variable is not a whole number. Now that you have learnt what is a monomial, how to find the degree of a monomial? Let's say 4x square y. You know what is a degree? Degree of monomial means it will refer to the sum of the degrees of all involved variables. Sum of the degrees of all involved variables. Any questions here?
What does it mean by degrees?
Degree of monomial means what I'll do. So there is an exponent of 2 and there is an exponent of 1. So 2 plus 1 equal to 3. 3 is the degree of this monomial. Makes sense? Now
So the addition
4
of
x power of 5 t. If I have this as a monomial, monomial means what? Product of a number and any number of variables, right? So degree of this monomial will be 5 plus 1 equal to 6. Did you get it, Ashwin, Diya?
Yeah, I understand.
Now, suppose if I have two monomials together. Two monomials together. See, this is called a term. One monomial, when they are summed, right? Meaning when you sum up the monomials, right? Then each of them, see, when you consider this, it's a term. Term means it's the product of numbers variables again. Monomials are called terms basically here in this. So this is called a term, this is called a term. Now, if there are two terms, terms are split by pluses or minuses, right? If there are two terms, let's say a function has two terms. See here, 2t plus 4t square. This is one term, this is one term. Now that's called a binomial. Make sense? Binomial means two, right? How about this, guys? What is this then called?
A trinomial.
A trinomial. Good job. Anything more than a trinomial. 4t power of 4 plus 3t cube plus 2t plus
Polynomial.
4t 2t plus 2t square plus 4t plus 1. So what is this then called? Anything above three terms is called what? Polynomial. Many. Make sense, guys? Make sense? Okay, now what about degree of polynomials? I told you about degree of monomials. What is this degree of polynomials? Let's see. 12 t square y plus t square y square plus t to the power of 4 y square. Let that be 8. Now, what is the degree of this polynomial? You know what I'll do? I'm going to go over this with you guys first time. Now, the degree of this monomial is 2 plus 1 equal to 3. The degree of this monomial is 2 plus 2 equal to 4. Sum of all the exponents of the involved variables, of the variables involved. Here, the degree is 4 plus 2 equal to 6. Now, we are not talking about the degree of the monomial. Degree of the polynomial will be the highest among these. Which is the highest? So the degree is 6. So the degree of this entire polynomial is 6. Any questions, guys? Any questions?
No.
Okay. Okay. Now, how about this? How about this? Is this a monomial or not? Dia, you tell me, Dia. Is this a monomial or not?
No,
Is that why?
because when you take it out of the fraction, the exponent's gonna be negative.
Good job. So it's not a monomial. Very nice. Now you tell me, you guys work at it and tell me what type of okay. I'll give you two questions, okay? 1 plus t square plus t. Okay, I just want you to tell me what is the type of polynomial here. Okay, the next one what I want to do is find the degree of the polynomial. Please answer both in chat. I want to see how you do. What is the degree of this polynomial is t square y plus t cube y cube plus t y. So what is the degree of this polynomial? Okay, send it in chat, guys.
Wait, you have to find the type of polynomial and degree for both?
Illemma, see, the first question is asking for type of polynomial. Second question is asking for degree.
Oh, okay.
Did you get
Yeah.
that? Mm-hmm.
Yeah.
Okay.
No,
Go ahead.
it's sending as 1. I'm typing in 2 dot, but it's sending it as 1. Alright. I'm just gonna delete it.
What, Panish?
It says that like I sent like it as 1, but it's saying it's like I put it as 2, but it's saying was 1. No, I just deleted it. It's fine.
I don't see anything that you sent in chat.
Yeah, I deleted it.
Ashwin, did you get the answer?
I'm almost done.
Mm-hmm. Go ahead, guys.
There's my answer for the second one. I forgot how to do the
Yes,
first.
Anish. Yes, Anish. Second one is correct. First one, did you do?
I forgot how to do the first one.
No
Like,
problem. Dia, for the second one, you have to find the degree of each monomial. The highest degree is the degree of the polynomial.
Okay.
Do you get it?
Yeah.
Ashwin, see, this is why I gave you this problem. One is as well a monomial. So, what is the type of polynomial, Ashwin?
Oh,
See,
so
Ashwin, one is 1x power of 0.
mhm.
So, what is this polynomial, Ashwin?
So it's a trinomial.
Yes, it's a trinomial. Anish, this is a term, this is a term, this is a term. How many terms are there, Anish? How many terms are there?
3.
What is the
Three.
type of polynomial if it is 3?
It's a trinomial.
Yes, that's right. Coming to the
Wait,
degree.
but then
Go ahead, ma.
t is like t power of 1. So like oh wait, never mind. I kind
You
of like
got it? Okay, good, good.
yeah. I understand.
Mm. What is the degree of the polynomial? What is the degree of the polynomial?
6.
6. Good job. This one, the degree of the polynomial here is, degree of this monomial is 3, degree of this monomial is 2, degree of this monomial is 6. The highest is 6, so the degree of the polynomial is 6. Can I move on? How do you write the standard form of a polynomial? How do you write the standard form of a polynomial? Let's say I have this. Suppose I have this. Is this polynomial in standard form? No, this polynomial is not in standard form. Then what is the standard form of a polynomial? When you write out the polynomial from left to right, okay, it has to be in the increasing powers of x. Increasing powers of x. Do you get it? It has to be in the increasing powers of x. So how do you convert it to standard form? I will write it down as 4x cube plus 4x square plus 14x plus 3. Do you see? When I go from left to right, the power of x is 3, and the power of x is 2, and the power of x is 1, the power of x here is 0. So it has to be in the decreasing powers of x. Did you get it, guys?
Yes.
Okay. How about this? What is the degree of this binomial? What is the degree of this binomial, Anish? What is the degree of this binomial?
Yeah, 7.
What is it, ma?
7.
Please.
7.
7. Good job. Good job. So this one is just 6. This one is 7. The highest is 7. So the degree is 7. Can I move on? Okay. Now, how do you adding polynomials? See, the only big thumb rule, these are all easy topics, okay? But the only thumb rule for adding polynomials is like terms are added. Like terms can be added together or subtracted. Both, see, adding or subtracting is just very easy provided you understand one thumb rule, added or subtracted. Only the like terms. What are like terms? X square y plus yx square. Are these two like terms? Are these two like monomials?
Yeah. Yes.
Yes, they're exactly the same. Y power is 1, x power is 2. So, see, whatever accompanies, the number that accompanies the variables is called coefficient. Right? Now, let's say in this polynomial, suppose in this polynomial, this is a standard form of a polynomial, right? The highest power of x, the highest power of t here has a coefficient, right? You know, the highest power of t, when it has this coefficient, you know what that is called? It's called a leading coefficient. Guys, you should be aware of these words. It's called the leading coefficient. Can I move on?
Yeah.
Okay. Now, these are called coefficients. Whatever number accompanies the variables, right? They are called coefficients. So, when you look at them, right, this is a like polynomial. Look at the variables. This is also y power of 1 x square. Both are exactly similar. So, you can add the coefficients or subtract the coefficients based on integer addition or subtraction leading to 2yx square. Any questions? Any questions?
No.
Let's go ahead and see. No, I have more questions for you. Let's see. So adding and subtracting polynomials is very easy. And one more thing, guys. Suppose if I ask you subtract 3 from 7. Please, you need to be careful here. Subtract 3 from 7. What do you do? What do you not do? You're not going to do this, right? This is incorrect. From 7 means it has to be 7 minus 3 equal to 4, right?
Yeah.
You know this already as a kindergartner. However, when you subtract, let's say 4x cube minus 1 from 16x cubed plus 12x square plus 1. If I'm going to subtract this binomial from this polynomial, how am I going to do? First I'll write
Like
the big
you just subtract with the like term, so then it's 12x cubed and then plus 12.
12x cube.
Yeah, 12x cubed plus 12x squared.
No, okay, but you missed one. Let's see. That's why you need to be very careful here. See, when you write this down like this, I will rewrite this as this. Okay, however, when you subtract, the subtraction is distributed across whatever monomials are inside. So that becomes minus 4x cube plus 1. So what happens here? 16x cube minus 4x cube will get you 12x cube minus 12x squared, right? And then minus
Plus 1.
4x plus 2. You got it?
Yeah.
I'm sorry. Okay. Did you get that? 12x cube minus 12x square plus 2. Any questions? You need to distribute the minus. Distributing the minus, usually everybody makes mistakes. Can I move on and give you problems with adding and subtracting polynomials? Ashwin, can we go ahead and do problems in polynomials, adding and subtracting?
Yeah.
Okay, so basically any polynomial f of x can be written as an x power of n plus an minus 1 x power of n minus 1 an minus 2 power of x minus 2 and then what? N minus 2, and then it keeps on going till a1 x power of 1 plus a0. A0 is the constant term. An is called what? Who can tell me what is an called? We did discuss this. What is an called in this polynomial? What is an, ma? It has got a name. What is an minus 1? What is an minus 2? What are those called? The number that accompanies the variables, what are they called? Diya, can you tell me what is it called?
Isn't
The
it
number. Huh?
exponents?
No, the number that accompanies the variables. Write one example and see. I'm asking 4x square plus 3x plus 1. In this, I'm asking what does this stand for? 4, 3, 1.
A
What are they called?
coefficient.
Coefficient. Similarly, the highest power of, so these are called coefficients, right? But what is an in particular? An is the coefficient that accompanies the highest power of x. So what is it called?
Leading coefficient.
Leading coefficient. Good job, guys. Leading coefficient. Okay, now let's go ahead and try this one. I'm going to give you a couple problems on polynomial addition subtraction. Okay, so you know what is a monic polynomial? Monic polynomial is where the leading coefficient is 1. Does that make sense? Monic polynomial is one where the leading coefficient of the polynomial is 1. Make sense, guys?
Yes.
Okay, good. How about this? Okay, you're going to do this. Okay, let's see. We'll do this problem entirely. Let's try this one. Try, guys. I feel so sleepy. Go ahead, guys. Go ahead. X cube minus 4x plus 7. G of x is this. You have to add the polynomials, subtract the polynomials, and then the third question is tad bit tricky. Find the constant c. For what constant c does this polynomial f of x plus c g of x have a degree of 2? Go ahead, ma. Did you get it? I want you guys to be able to answer. Did you get it? Anish?
I got A.
Anish? You got A. Good job. Shall I do it on the board? Please, please. Go ahead and do it and send me the answer for B and C particularly. Addition is very easy, guys. X cube. See, you can do it vertically or horizontally. One is vertically. Just align them properly. Okay. Now, when you add them together, this becomes minus 2x cube plus 2x square remains the same. Minus 4x plus x becomes minus 3x. That's it. So, this is the sum. This is the answer for A. How do you subtract them? F of x minus 4x plus 7. The minus needs to be distributed. Usually that's the problem. Usually that's what we tend to forget. And if you forget, you're not going to get the right answer here, right? So let's see this one. When I do that, x cube minus 4x plus 7 plus 3x cube minus 2x square minus x plus 7. See what happens? This x cube and 3x cube can be added together.
So 4x.
4x cube minus 2x square, and then minus 4x and minus x can be combined together plus 14. So
I got
this,
that.
yeah, that is B. Okay, now they're asking for, I should not have erased. For what constant C does this polynomial, what is on this polynomial, for what constant C have a degree of 2? If this polynomial should have a degree of 2, which term should get cancelled? Which term should get cancelled? Which term, meaning, see, for what I want this polynomial C, okay, C g of x means what? Let's do that first. Meaning f of x is x cube minus 4x plus 7, that is f of x, plus C times g of x is what? Minus 3x cube plus 2x square plus x minus 7. Now when I combine them together, I'll say, see, this and this, x cube minus 4x plus 7 minus 3cx cube plus 2cx square plus cx minus c7. Right? Here they want to have a degree of 2, means this has to get cancelled, right? Then only this polynomial will have a degree of 2, which is the highest exponent of x. Yeah, so this minus, so for what constant C does this polynomial have a degree of 2? That means somehow I want, see, there is an x cube term. So let's separate that out. That has to become 0. Only if that term x cube minus 3c x cube should become 0. How to make it equal to 0? Take x cube as common. You can say 1 minus 3c equal to 0. That means 1 minus 3c will be equal to 0. So 3c will be equal to 1. C will be equal to 1 by 3. Any questions, guys? If you substitute c is equal to 1 by 3 into this function, the polynomial will end up in getting this cancelled off, those cube terms cancelled off, and the highest degree of x would be 2. You get it? Whatever they've asked would be achieved. So c has to be equal to 1 by 3. How did I get that? I equated the cube term to 0. I found out what is the cube term in this. These two combined should become 0. Then only the degree will become 2. Diya, Anish, did you get that problem?
Yes.
Okay, I'll stop here, guys. And yeah, multiplication. I did multiplication. Indeed, I went to division with the other group. But next week when you come back, just remind me to go over multiplication. Just do problems on addition, subtraction this week. Any questions for me?
No.
Okay, guys. Then I'll see you all next week. Have a nice week ahead, guys. Sure.
Thanks. Bye.
Bye, ma.
We have class next Saturday?
We
No,
don't.
Shreya
I have to
does
see,
things
let me see the calendar, ma. I have to have one more 1.5 hour class, so I will be having that. Don't worry at all. But let me see. Next Saturday, I need to check. Anish, mom, I'm checking.
and you know.
Give me a minute, Anish, mom.
Oh, okay, no issues. I think you have another class. We can touch base later.
I can quickly check and tell because I don't want to confuse the kids, right? When they ask, hold on. I'm just checking the calendar, okay, literally. Hold on.
Okay.
I don't remember what we did, but anyway, we have to make up one more 1.5 hours class. I'll do it later. Because see, algebra one I'm lagging. I wanted to go to geometry as soon as possible, but yeah, it's just taking time. And it's voluminous. The volume 1 book is, the algebra book is voluminous. So this week, 26 Feb. Where is Feb? Oh yeah. Oh wow. 27 and 28 have cancelled the class. Why? Why did I cancel? Yeah. Yeah. 27 and 28 have cancelled the class. Okay. That's good for me. See, because I am traveling back on the 27th. 28th I reach, but I don't know how it is going to be on the 28th. That is why I've cancelled the class. That is why that makeup only we cancel. So don't worry at all. We will be having the makeup the following week.
Okay.
That is on 7th. 7th I'll have a 1.5 hour class. Makes sense? 7 and 14 will be 1.5 hour classes. Make sense, huh? Okay.
Okay. Thank you.
But Anish mom, I've sent you a message just to
Bye.
have a look at it. Okay.
Yeah. Okay.
Yeah. Huh? Okay. Bye bye. Mm. Hi guys. How are you all?
Good, how are you?
Good ma. Okay. What Parvini, what are you doing in school? Vectors or polar graphs?
We're doing the trig identities and stuff.
Oh, trig identities only.
Yeah.
Okay, that's interesting.
Yeah, we're doing trigger identities. I'm testing.
Trig. Okay. Mano, how about you? Double angle. You're doing double angle.
Yeah.
All that you're doing. Okay, so I'll be doing that. Meaning we did start with it last week, but I'll be continuing on that this week. You know what? You have to give me 1 minute. My charger is going to go off. You're going to give me a minute, guys. Guys, sorry to make you wait, guys. Give me a minute, okay? My charger is running out. I have to bring. Hi guys. Okay, let's continue with the trig identities. We did discuss Pythagorean identities and reciprocal identities last week, right? Parvini, what are you doing in school, ma?
We're doing like trig identities and verifying trig identities and stuff.
Come again? You're doing trig identities and what?
The solving the trig equations and verifying the identities.
Okay. Oh, solving trig equations and verifying identities. Okay, good. That's okay. That's something we started last week, but we just used Pythagorean identities and reciprocal identities, right? Okay, let's go ahead with that. Hold on. Okay. We didn't do 13.12. Akash, you're also doing trig identities? Akash?
Yeah.
We just finished that. I think we're doing inverse trig and solving trig equations.
Inverse trig and solving trig. Okay, yeah. Okay, let's do this one. You finished trig identities, ah?
Yeah.
Did you solve sine alpha plus beta or sine A plus B?
No, that's on our
We
next
just
test.
proved it was. We had like two sides of the equation. We had to prove they were equal.
No, we
Oh,
only
yeah,
did.
yeah. So you're doing
But
trig
we haven't had our test over sum and difference. All those sum and difference, double angle. But we're learning about them.
Yeah, so some difference identities. Okay, today we are going to cover some different identities and double angle identities mainly. Okay, so we should be able to solve problems with that. Coming to solving trigonometry, I just want to verify what you're all saying. Let's see. Okay, but we'll continue with what we did last week and then go ahead, is what I feel. Hold on. Let me quickly check where we are. Okay, how about this? But I want to continue with what we did last week and then go to inverse solving. Let's see. Let's see. Okay, let's see this one. How about this? Okay, can you let's see. Can you simplify this? We'll start with easy ones, guys. Can you simplify this? See, this is just based on what we learned last week. Simplify this. We are getting two problems. We are just continuing with what we did last week. Can we do these two? If you're stuck, I will do. This is just based off what we did last week. There is no difference identity or double angle identities in picture here. You want me to do? Just let me know. I'll do it. Dhwani, you are Dhwani and Krish. What you're doing in school, guys?
We're doing trig identities, like we've done the Pythagorean and the cosine sine, and we started like the sine a plus or minus b, and like same thing for cosine and tangent.
Yeah.
Good. Done? Did you get the answers? Yes, I'm seeing your answer. If you don't know, you don't know. Shragvi, what are you doing, Shragvi?
We're also doing trig identities.
Okay. Mm-hmm. Did you get it? I did get a couple of answers, none. Okay, Advik. Oh, wow. Okay. The 2 by cos x is right. I don't know. First one is right, Parvini. Dhvani, first one is tan x, right, ma?
Oh yeah, sorry.
No
I
problem.
didn't
So you can
cancel. I mean, I canceled the tan on accident.
not at all a problem, ma. 1 plus tan square x. Okay. So this would be 1 plus tan square x minus 1 divided by tan x. So this one tan square x by tan x will be equal to tan x. Okay. The second one, Lopa, are you solving? I'm going to take the least common multiple. Cos x 1 plus sin x is the least common multiple. That being the case, here this fraction needs to be multiplied and divided by 1 plus sin x, so that becomes 1 plus sin x the whole square. The next one, cos x and cos x, right? So there it will become cos square x. So when I expand this, 1 plus sin square x plus 2 sin x, formula a plus b the whole square, plus cos square x, I'm rewriting this here, divided by cos x 1 plus sin x. So when you look at this and this becomes 1, right? So that would be cos sin square x plus cos square x equal to 1. So what happens here? 1 plus sin x divided by cos x 1 plus sin x. So this gets cancelled. Answer will be 2 secant x. Can I move on? Okay, we started with simple ones. Let's see. Any questions, you'll have to stop me, okay? So let's go ahead and try a harder one. Let's see. How about this? That's a good one. Let's see. Okay, now I want you to solve for x within this. I want you to solve for x with a restricted domain. I want to solve for x with a restricted domain. I hope you all have the unit circle in your brain. Let's try, guys.
Solve for x.
Yep. Solve for x. Okay, there's something that you cannot be doing. So I want to explain that for sure. Hold on. Do you want me to write out the unit circle or you're all by yourself? I don't know. Unit circle is here if you want to, but the next problem I won't be having the unit circle in place. Now here, basically see clearly it's a quadratic equation. So what I would do is I would take it as t. 2t square minus t minus 1 will be equal to 0. So in that case, how to get this trinomial factorized, and then using the zero product rule, you can equate each of the multiplicand to 0, then you'll get your theta value. So let's try that. If you don't know or if you get stuck, I'll help you. Akash, are you getting the answers, Akash?
Yeah.
Okay. No, what I thought of... yeah, we'll solve more trigonometric problems. We didn't actually... Using, see, the restriction is 0 to pi. Only between 0 and pi, 2 pi, you need to find out values. So factorize this and then find out the values. Let's see. You get it? is, see, if you didn't get it, you have to ask. Lopa, are you getting it, ma? I'm waiting for answers.
Yeah,
Should
I'm
I
getting it
solve
right
it on the
now.
board? Then I'll. What, ma?
Oh, nothing.
Lopa?
Can you explain it
Yes,
a
I
little
can.
bit? Yeah, I
So
kind of.
here, yeah. So 2t square minus t. So product is minus t. Product is minus 2. Product is minus 2. That's the product. And sum should be minus 1, right? So what can get you that? How do you factorize it? So product is minus 2, okay, and the sum is minus 1. So minus 2t minus t. See here, the minus 2t plus 1t. So that gets you the product of minus 2 and then the sum of minus 1. So I'll go ahead and factorize this as 2t square minus 2t plus t minus 1 will be equal to 0. Taking 2t as common, that will become t minus 1 plus 1 t minus 1 will be equal to 0. As a result, 2t plus 1 t minus 1 will be equal to 0. Did you all get that till there? Now, each of that can be equated to 0, correct? So that gets you to, I'll do it on this side. Now 2t plus 1 will be equal to 0. What does that mean? Or you can as well have t minus 1 equal to 0. If for the first one, if you solve right, t will be equal to minus 1 by 2. The second one, if you solve right, t equal to 1. If t equal to, see sine, this is t is equal to, what did we assume? Sine x is t. That's what we assumed, right? We substituted sine x as t. So sine x will be equal to minus half or 1. Where is sine x minus half? Where is sine x minus half? Here all is positive, 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 positive. Where is sine negative?
7 pi over 6 and 11 pi over 6.
Yeah, 7 pi over 6 and 11 pi over 6. When you look at it, 7 pi over 6, 11 pi over 6. You have to mention all the values. And where is it 1? Where is it 1? That's the only place where it is 1. So that is pi by 2. So the x value can be pi by 2, 7 pi by 6 or 11 pi by 6. In this interval they have clearly given. Any questions? Any questions? Advik, did you get it, Advik?
Yeah.
Okay, how about this? Let's see. I really want you to do more of this. Okay, let's try a couple more problems that are similar to this. This trig equation solving I have not yet done much. Yama?
I have a question. So,
Yeah.
wouldn't you find the period and keep adding until you reach like?
Yes. We will do that. We will always find the period and keep adding that using n, right, ma? K pi or n pi you will keep adding. However, that need not be done if you're given the restriction. If you're given the domain as 0 to 2 pi, you will have to find angles only from 0 to 2 pi. That's why we didn't do that, Parvini. Make sense?
Yeah.
Okay, how about this? I don't know. Let's see. Okay, how about this? Okay, let's see this one. Not a hard one. You can do it yourself. This one, let's see. Okay, how about this one? You're going to try this one and tell me, I really want you to solve in the same interval 0 to 2 pi. I would like you to solve in that interval itself. Can you do that for me? Let me write out the interval as well. You're going to do it by yourself. But a very similar problem is this one. Interval is 0 is less than or equal to x is less than or equal to 2 pi. Please consider this interval, solve for x. I have given the unit circle as well here for you. Go ahead. Let me know if you need help on this. Shragvi, would you be able to proceed with this?
Yeah, I can try.
Okay. Let me know if you need help, guys. Is that the only value, Manav? I am not
Let's
sure.
do the last one.
Okay. Yeah, this one is a good one. Let's see. Let's see. If you don't get it, I'll solve on the board, guys. But you have to try. Assume sin x will be equal to some variable t. Then factorize the equation. Use a zero product rule to equate each of the multiplicand to 0. Once you do that, you will have several values of theta. Krish, are you able to do?
Yeah, I'm almost done.
Yes, Parvini. Parvini, you're also doing trig identities, Parvini.
Yeah, we finished this already. We had our summative test on this.
Oh, summative test. On what are you doing then? Oh, you're doing the identities.
Yeah, we have a quiz over tomorrow.
We'll do double angle and difference. I have a question, a curious question. Have you derived the formula for difference identities? Have you derived the formula for difference identities, Parvini?
No, we only did like Pythagorean quotient and reciprocal identities.
Oh, difference identities you have not yet done?
No, we learned how to verify the trig identities, but like we haven't learned difference identities.
I see. Oh, so double angle as well is there, Rama?
Yeah, it's on the agenda to learn for tomorrow.
Okay, that's fine. Okay, done, guys. Yes, Krish, that's right. But why did you? Okay, Parvini, that's right. Others, I didn't get the answer. Akash, Manav, did you get the answers? Lopa,
I have the
Shnagvi.
answer, but I'm just checking.
Okay, sure. Advik, did you get it? Shri, come on the video. Dhwani, you're not on the video.
Miss Priya, there's for some reason there's like a lot of background noise coming from your end. I don't know why.
Okay.
It's like something like some like tapping sound or something. Yeah, I don't know.
Do you still hear it?
No, no.
Interesting. Now?
No.
Oh, then there's absolutely no one here though. Go ahead. But let me know if you hear it. Go ahead, guys. Did you get the answer or do you want me to solve on the board? One of you, please tell me, guys. It's so hard. Otherwise.
Miss Priya, could you do it on the
Yes, absolutely. I'll do it on the board. Manav, you're missing. Manav, you're missing values. Manav, I don't know what. Let's see. So I'm assuming sin x equal to t. If I do that, this becomes t square. This becomes t. So I rewrite this equation as 2t square plus 3t minus 2 will be equal to 0. How do I factorize it? Product is 4. Product is 4. Sum is 3. So what do I do for it? Product is minus 4 if you think about it. So it will be it will be plus 4 and a minus 1. Plus 4 and a minus 1 works. So 2t square plus 4t minus t minus 2 will be equal to 0. So once so here see 2t, take out 2t as I'm not able to write. Take out 2t as common, it becomes t plus 2. Take out minus 1 as common, t plus 2 will be equal to 0. So t will be equal to minus 2 or 1 by 2, right? Here the problem is t was what actually? Sin x. Sin x can either be equal to minus 2 or 1 by 2. Can sin x be ever equal to minus 2? No, this is an invalid solution. It has to oscillate between -1 and 1, the parent function, right? So sin x can't be equal to -2. Sin x can only be equal to half. Where is it equal to half? Positive half. When you look at it, this or there are two values, right? This or this. So what are the answers? Pi by 6 and 5 pi by 6. Manav, did you get that?
Yeah.
Okay, so see the interval given is 0 to 2 pi. So you have to include all the values between 0 to 2 pi where sin x will be equal to half. Shragvi, are you following?
Yeah.
Advik, did you follow?
Yeah.
Okay, let's see this one. I don't want any double angle identities yet, but let's see. Let's see, guys. Give me a minute. I want to do more of these. Okay, how about this? I want it in a restricted interval. Unrestricted interval is when you have the pi. Okay, now let's see. Given this, yeah, I wanted to be able to calculate this. I think we did this though. I feel like we did the same problem. Okay, how about this? Can you tell me the range? Can you tell me the range and vertical asymptotes of this? This is just a review problem. Can you tell me the range and vertical asymptotes of this function? Here, you have to tell me the range and vertical asymptotes. Usually, the frequency, the period is pi, but there is a b value in here. Basically, that b value is what? There is a b value in here which is 2. So what happens to the vertical asymptotes?
They are horizontally dilated by 1/2.
Yeah, dilate by 1/2, but range is what, ma?
Wait, how are we supposed to write the vertical asymptote?
How are we going to okay, so usually in a chord function, where are the okay, first write
Do we
remember
write the equation or just a few?
no, right, Manu, you know, for the parent function, where is the vertical asymptote?
Yeah.
But then there is a phase shift of pi, but the phase shift of pi is there. However, the period of that function is also pi, so you don't even need to bother about this. But then you need to be bother about this too. Usually for a parent function cortex, the period is pi. Here there is a, this is like a cot b theta, so it should be pi by b plus, do you remember
write
what
the equation?
for the vertical asymptotes? Where will the vertical asymptotes be is just the question, right? So it will be, see, for every pi by 2, first see where the first asymptote will be. The first asymptote will be at pi by 2, right? And then plus pi by 2n. For every pi by 2, there is going to be a vertical asymptote because of that horizontal dilation. Make sense? Yep. Can I move on? Now, I want to do one or two problems in this as well more. Let's see. How about this? I would like you to try this one. Easy ones, let's try. How about this? Okay, how about this? Shall we try this one? This is no restrictions. Whenever there are no restrictions, you have a lot. 2 cosecant x minus pi by 2 plus 1. 2 cosecant x minus, this is again a review. 2 cosecant Oh my god, what did I write? 2 cosecant x minus pi by 2 plus 1. Would we be able to graph this? Okay, first of all, you graph it. Where are the vertical asymptotes? Would you be able to let me know on that? And you can also let me know the range. I'll try to get the graph for you. See, it's a cosecant graph. However, it's phase shifted by pi by 2 to the right and 1 up. And then there's also vertical dilation of 2. So what do you do? You're going to let me know, guys. Would you be able to tell me the range and the vertical asymptotes? Graph we'll see. First draw the midline. Midline has been shifted from y equal to 0 to 1 up. After that, look at the amplitude. It's 2. 2 up and 2 down. However, for cosecant, right, I would go ahead and draw the sine function first. The problem with the sine function is it's phase shifted by pi by 2. So what happens, you need to find out. If it is phase shifted by pi by 2, that's a little tricky. Pi by 2 to the right. So the 0 point starts at pi by 2 on the right. We'll see. I'll wait, guys. I really want to know the graph. What graph you draw. If you want me to draw, I'll draw as well. Okay, let me go ahead and draw. Okay. So if you have this right, midline is shifted 1 up. Because of the plus 1, midline is shifted 1 up. So basically, in a sine graph, it would have been like this, right? But the sine graph is phase shifted. We need to understand that. So, 1 second. Okay, the sine graph is phase shifted, but let's see first, okay? 0, but the amplitude is 2, right? So let's say amplitude is 2 means it will go here. Here the amplitude is 2 means it will go to this point. So this is your midline. So what happens here? Cosecant, right? So, but it is a phase shifted pi by 2 to the right. So 0 comes here basically. Usually your sine graph would have been what? It starts here, pi by 2 it goes up, and then what happens? Pi, it goes to again 0, 3 pi by 2, it goes to the negative end, and then it goes up. But this is only the sine function, right? And it is phase shifted to the right. So what happens? Let me go ahead, erase this off. It's phase shifted pi by 2 to the right means everything moves to the right by pi by 2. So in a sine graph phase shifted by pi by 2, you will have from here, it goes up here, and then it goes to 0, the midline, and then it comes to, see here the amplitude is as well 2. So let me cater to that as well. It goes up like this, comes down, and then what happens? It goes to the negative, it goes to the negative end, right? So here it is shifted, phase shifted pi by 2 to the right. So now it comes here, negative, and then it goes here, then it goes up. However, this is the sine function, guys. This is just the sine function. So your cosecant would be what? Cosecant would be a reciprocal function, right? So for this one, the graph would be like this. The real graph would be like this. So wherever you have this, it's going to go ahead and have it like this. Your asymptotes are going to be wherever your sine is 0, asymptotes are going to be there. Asymptotes are going to be here, going to be here. Wherever it is 0, asymptotes are going to be there. So here, right? Now, how is the graph going to be? Your final graph is going to be like this. Like this. You see? So now what will be, this is the graph. The green ones are the graph. So what will be the vertical asymptotes, guys? Anybody please chime in. Dhwani, you want to talk about the vertical asymptotes?
Yeah, for this one, it was pi over 2 plus pi k.
Yeah. So the first vertical asymptote is pi by 2, and then after that it repeats for every pi k. So this is the vertical asymptotes, whereas the range would be what?
It would be
Range is minus infinity to what is this? Uh-huh.
-1.
Yep, -1, and then -1 is included because this value is included in the graph, and then union, what is this point in the graph?
3.
1, 2, 3. So 3 to infinity. Make sense, guys? Shri Lopa, does it make sense?
Yeah, I understand.
Yeah,
Now,
I'm
let's
getting
go
it.
back to trigger identity. Okay, I want to cover trigger. Okay, I want to cover difference of identities as well. Let's see. Hold on. Let's see. How about this? Would you, I don't know, would you be able to solve this? Let's see. Okay, let's see this one. Would you be able to simplify this? Check. This is only on trig identities. We'll get back the unit circle again. Secant square x minus cosecant square x. Just simplify. Tan square x minus cot square x. It's not a hard one, guys. Try. If you don't get it, then I'll help you. Sometimes you can get things like this as well. Okay. Question number 1, question number 2. We'll simplify these. Let me know if you need help. 1 and 2. I would really like to get answers from each of you. These are all using Pythagorean identities, and then a square minus b square. See, the second one is a little tricky. Secant power 4x minus 1. Both are square terms. Secant power 4x is a square term, 1 is a square term. So it's more of like a square minus b square formula in the numerator. Once you apply that as a plus b, a minus b, then you will have a ton of factorizing to get to. Can we try that? Yeah, Dhwani. If you need help, you have to let me know. Shagvi, we didn't get to double angle identities, right? Is it that hard? Shagvi, where did we get there? Shragvi, where is the C? That is secant square x, right? Okay, secant square. Okay. Does that simplify to that? I doubt. Secant square x will be equal to 1 plus tan square x. Cosecant square x will be equal to 1 plus cot square x is what I'm thinking. So can you guys try and let me know what do you get? Or even you can simplify. There are multiple ways of simplifying. Guys, do you want me to solve or you want to solve?
Miss Priya, could you do this one?
Yeah. I'm just trying to do this because why I am simplifying it like this is I'm pretty sure the denominators will get cancelled as soon as I see this. If I take common denominator, secant square x minus cosecant square x, tan square x is sin square x by cos square x. See, denominators are matching, so I prefer doing it this way than using this. I don't need to, you can as well use this and simplify, but then I feel like the denominators will get cancelled. So cos square x by sin square x. So when you take the common denominator, guys, see, denominator becomes cos square x sin square x. Top will become sin square x minus cos square x. Okay, and then what happens? Let's see. Divided by, here as well, you take cos square x sin square x as common. So what you will get? Sin power of 4x minus cos power of 4x. So these two will get cancelled. So sin square x minus cos square x divided by, see, this is sin power of 4x minus cos power of 4x. Clearly, this denominator is of the format a square minus b square, where a will be equal to sin square x, b will be equal to cos square x. If I do that formula in here, what happens? Sin square x, I don't know what is the answer. Let's see. Minus cos square x. Sin square x minus cos square x is as well when you look at it, right? See. Let's see. This is as well a square minus b square. A square minus b square, right? A plus b, a minus b. Sin x plus cos x, sin x minus cos. Or see, okay, you don't need to expand this. We'll cancel that out. Sin square x minus cos square x. Denominator will be a square minus b square. So a plus b, a minus b. Sin square x plus cos square x. Sin square x minus cos square x, right? So now you don't even need to expand this. These two will get cancelled. So this one is a 1. So everything becomes a 1. Did you guys get it now? Akash, are you getting it, Akash?
Yeah.
Okay. Mano, second one is correct. I have to see, Mano. I don't know. Let's see. The second one as well, I'm going to do it by myself. Then let's go to difference of identities. Now, secant power of 4x minus 1. These things I really see clearly. My denominators will get cancelled because the denominator for this is 1 by cos power of 4x. Here this would be square x. So why don't I but before I go there, see, this is as well a square minus b square formula. So let me go ahead. A will be equal to secant square x, b will be equal to 1. So with that in place, right, a plus b, a minus b. So let me go ahead and do secant square x plus 1, secant square x minus 1. If I do that, tan square x, okay, there is one another Pythagorean identity where secant square x will be equal to tan square x plus 1, right? So there, tan square x will be equal to, see, then tan square, subtract 1 on both sides, tan square x will be equal to secant square x minus 1. So that I can substitute in here. Instead of tan square x, I can write it out as secant square x minus 1. So these two will get cancelled. Answer I get is secant square x plus 1. Right, Manav?
Yeah.
Okay. It's not a minus 1, right?
I think. Wait. Oh yeah, I think I may have accidentally written.
Yeah. See, one thing for you to remember that is, even I have made the same common mistake. See, the thing is, I always remember it as always secant square x will be equal to only cosecant square x will be equal to only the other side only will have the plus 1. Make sense?
Yes, Priya.
Yama?
Should I go over the first one one more time?
Yeah, sure. First one, what did we do? Okay, as soon as I see it, right, I feel like you can think of it in multiple ways, ma. Okay, so see here, this is a square minus b square. This is also a square minus b square. You can either do a plus b, a minus b, and then take the common denominator. Or what you can do, when I look at this function, when I look at this entire expression, right, the denominator of this is going to be cos square, the denominator of this is going to be sin square, the denominator of this is going to be cos square, the denominator of this is going to be sin square. So basically when I split that into simpler trig functions, right, and take the least common multiple, the denominator seem to be getting cancelled. So I prefer that 1 by cos square x minus 1 by sin square x divided by sin square x by cos square x minus cos square x by sin square x. Did you understand this?
Yeah.
How to take common multiple? There is nothing common, so just multiply them together, cos square x, sin square x. But if you bring it to the common multiple, this fraction, right, this fraction is lagging sin square x, right? So I multiply that in both numerator and denominator. As a result, my numerator becomes sin square x. Here, cos square x is missing in both numerator and denominator, so that will be equal to cos square x. Now I will divide the entire thing by, again, what is the common denominator? Sin square x cos square x. But this side is lagging what? This side is lagging sin square x, right? This side is lagging sin square x. So that becomes sin power of 4x minus cos power of 4x, right? This gets completely cancelled. Numerator by denominator. This is fraction division, right, ma? Or otherwise, other way of writing this is sin square x minus cos square x divide by cos square x sin square x. You cannot divide fractions, right? So you multiply and flip. When you flip it, sin square x cos square x divide by sin power of 4x minus cos power of 4x, right? This get cancelled. This as sin square x minus cos square x. But denominator you can take it as a square minus b square. So a square, a plus b, a times a minus b. Makes I had a problem with my internet. Make sense, Parvini?
Yeah.
Parvini, does it make sense?
Yes.
Okay, absolutely. I had a problem with my internet. Okay, let's simplify this. You're going to try this one, guys. You're going to try this out and tell me. Simplify this. I really want to go to difference and double angle identities right today. Go ahead and try this one. 1 minus cos x by sin x plus sin x by 1 minus cos x. Please take LCM. Use Pythagorean identities and let me know what you get. Final answer alone you can send if you get it right. Can we try this? Did you get it, guys? Guys, this time please you do, guys, all of you. No point in me doing. If you're stuck, you have to let me know, guys.
I'm a little bit confused.
I'll help. Manav, that
Okay.
seems right. Manav, that seems right. Others, okay, if you're confused as well, put it out, right? Then only I'll know. Correct, Mashra Agdi. Advik, correct. Very nice, guys. So, so I'm going to go ahead and do it for Shri. Lopa, did you get it? Krishav, what are you doing, Krishav?
Yeah, I'm sending it right now.
Yeah.
I'm
So
about to.
here, see, there is nothing common. Multiply them together. Sin x, 1 minus cos x. Now, the numerator, what is lagging here? 1 minus cos x is lagging. So that becomes 1 minus cos x the whole square. What is lagging here? Sin x is not present. So you multiply by sin x in both numerator and denominator, that becomes sin square x. Having said that, this is of the format a minus b the whole square. So a 2ab. Okay, now if I do this, denominator is sin x, 1 minus cos x. Now I add these two to get 1. 1 plus 1 will be equal to 2. This simplifies to 2 plus 2 cos x divided by sin x, 1 minus cos x.
Isn't
Did I
it
make a
top
mistake?
one,
Yeah,
right?
yeah, yeah, yeah. I know I made a mistake. Huh? This one is a minus b the whole square. So the minus has to be there, right? So you will be able to find out your own mistakes very easily if they don't cancel out, guys. So here, take 2 as common. 1 minus cos x divided by sin x, 1 minus cos x. So this and this will get cancelled. 2 by sin x becomes 2 cosecant x. That's the answer. Shri, did you get it?
Yeah.
Miss Priya.
Shri, did you understand?
Yeah, I
Yes,
got it, kind of. Yeah, I'm getting it.
yes, I'm here. Did you have any questions?
Miss Priya,
Dhwani,
I
did you
have
have
a
any
question.
questions?
Yeah. Could you also like multiply like
Yeah.
the numerator by 1 plus cosine x, so you can simplify 1 minus cosine squared x to just sine squared x.
Come again, ma. Dhwani, tell me, tell me once more, please. I will do it whatever you say. Tell
Like
me.
multiply the first fraction by 1 plus cosine x
Okay, wait. So you want to multiply by 1 minus cosine x, okay?
plus
Sine
plus
x.
plus x plus cosine x.
Yeah, I got it. Okay, I did this. Okay, and then what will you do with the second fraction?
You multiply that also by
1 plus
1
sine 1 plus
plus
cos x.
1 plus cos x.
Um, mm-hmm. Um, if you do that, what is the advantage? Okay, let's see. If you do that, this would become 1 minus cos square x, correct?
Yeah, that would become
1.
sine x. And the
Okay.
other one,
The denominator, there's no common denominator, right?
oh
You see
wait,
that
okay, I totally forgot there's a plus sign and not a multiplication sign. Because I
which
canceled them both out. I forgot there was a plus sign. Never mind.
oh, okay, this one, okay. So see, okay, how to make a choice though, meaning as you're all getting into this new meaning with practice the more you solve you'll know what to do. Here clearly you have to take the LCM. When you take the LCM, what happens is this becomes a minus b the whole square, this becomes sine square x. So clearly once you get that, you can apply Pythagorean identity to simplify that. Okay, so let's do one or I don't know, I would like to do more identities, but I also want to cover the let me go to double angle identity, because last week itself we started with it, right? I mean, I started with the difference identity. I just gave you the formula. I wanted to derive, but let's see whether I can derive. That's 3.13, right? Give me 1 second. Recent. I just need to do 3.13. Where is 3.13? Yep. No, that's not it. Hold on, guys. Jojo. 3.13. 3.12 AB. Yeah, I think that's 3.12 AB. Okay. Makes sense, guys. So, how about this? We did not do this at all. So, first let's go to the double angle entity. I'm going to give you the formula right away, but definitely I want you to. Pythagorean and reciprocal we did last week. I showed you how it works as well. But coming to difference here, you need to understand this: sine a minus b, then sine a plus b, then this is sum and difference identities, then cos a minus b, cos a plus b. I can show you one derivation in this, but let's see whether we want to. It's good to really understand how these are derived, but let's see. Now, I'm going to write out for sine first. Sine A cos B. See, sine and cos are always mixed, but then whatever is in here will work. Minus cos A sin B. Sin A plus B will be equal to sin A cos B plus cos A sin B. Cos A minus B is a little different. Okay, for this one of this I'll try to get the derivation. Okay. So this would be cos A cos B. ஒரு நிமிஷம். Okay, so here cos A cos B, so here it will change plus sin A sin B. See, cos, whenever there is a minus, the other one comes. So sin A sin B. Here cos A cos B minus sin A sin B. I have given you the formulas directly. I have not derived anything, but I would like to show one of the formulas. It's okay, let's see. So this is the difference in some identities for sine and cos. Any questions? Meaning I've just given you the formulas I know, but we can cleanly derive one of this, and I can show you sin A minus B equal to why it is equal to sin A cos B minus cos A sin B. We can derive, but first note this down. You'll have to get this to your brain. Can I move on? We'll move on with this. I'll show you a couple of problems, then see if we have time for derivation. I'll definitely do the derivation. Did you guys get it? Did you guys copy this down? It's important. Now let's go ahead and do this one. Sine pi by 4 plus 5 pi by 3. Sine pi by 4 plus 5 pi by 3. What identity can you use here to expand this, guys? What identity can you use to expand this?
Sine A plus B.
Yup. Can you do that for me? Can you do that for me?
Yeah.
Uh-huh. Say, really want you to derive that. Let's see where we are. Let's see. Go ahead, guys. What did you get? For sine, did you get it? Did you get it, ma'am? All of you, please, you can do this by yourself. I think it's just using the. Okay, I'll be using the I'll be using the sum identity, right? So sine pi by 4. Sine will always be mixed, right? Cos 5 pi by 3 minus sine pi by 4, sine 5 pi by 3 cos pi by 4. Can you do this yourself? Just plug in values and find the final value and tell me. You have to use the identities properly, that's it. Can you go ahead and do and tell me the answers, guys? You're going to try doing this. Pi by 4 is root 2 by 2 and 5 pi by 3 is what? 1 by 2. Plug that in and then 5 pi by 3. Sine 5 pi by 3, you need to find out what it is, and then cos pi by 4. Please substitute and send me the answers. I've got only a couple of answers. Shragvi. No, Shragvi. You have to find the exact value, Shragvi. You cannot use calculators on these. Am I making sense? 3 square root of 2 by 4. Why? Okay, let me bring up the unit circle and show you as well. I'm a little lost, ma. Dhwani, how did you get that? Okay, let me show you.
Once I found the individual values, I added them.
You found the individual value and added them.
I mean,
Yeah.
I didn't add all of them. I also had to like multiply before I added them.
But something feels very wrong. Okay, let me see. I don't
I
know what
can
feels very
check it again.
Yeah, definitely check it again. I feel like something feels really wrong. Okay, let's see. Advik, are you able to substitute? Akash and Manav, are you substituting and finding the values? Okay, I've given you the unit circle as well here. So, what is sine pi by 4? This is, what is sine pi by 4? Root 2 by 2. What is cos 5 pi by 3? What is cos 5 pi by 3? Half. What is sine 5 pi by 3? What is sine 5 pi by 3? Minus root 3 by 2. What is cos pi by 4? Cos pi by 4 is again root 2 by 2. This being the case, root 2 by 4, root 2 by 4 plus, what is this? Root 6 by 4, right? Let me quickly check. So this would be common denominator 4 root 2 plus root 6. This is the exact value, right, guys? If you're not going to use a calculator, you don't need to add any of these. You can just tell the answer in terms of whatever you get. Yeah, ma? Minus, right? Yes. Yes, ma. Which one? Which one is?
The root 6.
This one is a plus, right, ma? Should have been this. Is this what you wanted to say, Parvini?
Yeah.
Yep. So answer is root 2 minus root 6 by 4. This is how you find exact values of whatever trig functions they ask if you are going to use the sum or difference identities. Now, okay, let's see. Let's do a few more. How about this? This you are going to try by yourself. Cos 7 pi by 4 minus 2 pi by 3. Cos 7 pi by 4 minus 2 pi by 3. Can you do this one for me? It is also using the difference identity of cos. Can you do that for me? You have to find the exact value. So, I will go ahead and give you the double angle identity, solve a couple of problems. Then we'll see whether we can derive or we can derive it next class. I want you to do more problems on this. Let's see. Some difference. Did you get it, ma'am? Guys, I'm waiting for your answers. I'll not solve. If you need help, I'll solve. What's the answer to this? See, it becomes complicated when you mix and match identities later. That we'll do next week, but at least we want to do some difference and double angle identities separately today. The more problems you do, the easier it is. Manav, is that right, Manav? Is it just minus 3 square root 2?
That was the last one.
Yeah, but for the last one as well, that was not the answer, right?
It's divided by 8.
Huh?
It's divided by 8.
Manav, is this the answer to this question or the previous question?
Oh, this is the previous question.
Previous question as well, Manav. The previous answer was square root of 2 minus square root of 6 by 4, right?
No.
Yeah, I showed it on the board as well, right? Okay, do this one, then you'll know. Do this one, we'll see where is the error. Because it's exactly similar, but cos. Can you try? Parvini, are you not getting a negative in the numerator? Everything is right, ma, but the sign is incorrect. Are you not getting a negative on the numerator? Advik, are you doing Advik? Krish, are you doing? Or if you don't know, you have to let me know, guys. You're going real slow. Did you guys, Sri, are you working?
Miss Priya, I thought
Yeah, go ahead, ma, Parvini.
I thought the negative from the 2 pi over 3 would cancel out with the other one.
Oh, you're still getting positive?
Yeah.
Okay, let me see. I'll work it out on the board. I'll check. Yeah, Advik, that seems right, Advik. Okay, Parvini, I feel like something is wrong, but I don't know, ma. Advik, his answer seems right to me, but let me see. This is cos A minus B, right? Cos A minus B is always same. Sign is always mixed. That's how I remember. So this is cos A cos B minus, this is plus sin A sin B, right? So here it's going to be cos 7 pi by 4 cos. Akash, are you doing?
Yeah,
What is the answer, Akash?
Miss Priya.
I'm confused. I'm confused on how I get from the cost 7. I'm still confused on like the doubling.
We are only doing. Where you're getting confused, Akash, I just substituted the formula, right? Cos A minus B.
Mm-hmm.
Cos A minus B, sin A minus B. Sin is always mixed. When I do it, sin A cos B will come first. It's always mixed. But then the sign is always the opposite in sign. So sin A cos B plus cos A sin B. Make sense? Cos is always the same, cos A cos B, but the sign will always be the same. Make sense? So here I plugged this in, that's all I did. You got it? Yeah.
When you first wrote the formulas, you said it the other
Wait,
way
wait.
around.
Okay. I confused. I'm sorry if I confused. Hold on. No. I think I confused the formula here. Let me write it down. Cos, the sign will always be different. Cos, the sign will always be different. Okay. Here only I confused, ma'am. Cos, the sign will always be different. Sign, because of mixing, we'll have the sign the same. So cos, we'll always have, see, because it's the same, the signs are different. The signs are different means it'll be a plus in here. Will be a plus in here. So let's see cos.
Priya?
But Advik got it right? Yes, ma.
Would we not put it as negative 2 pi over 3?
Why?
Because it's
Why negative?
minus.
But you are taking the cos A minus B formula, right? Parvini, if you are taking the cos A plus B formula, then you substitute A equal to 7 pi by 4 and B will be equal to minus 2 pi by 3. If you take the cos A minus B formula, A will be equal to 7 pi by 4, B will be equal to 2 pi by 3. Make sense?
Oh, yeah.
I don't want to confuse myself with this. I want to go with this directly. You get it?
Yeah.
Does it make sense?
Yeah, it makes sense.
Okay, so here I am going ahead with cos A minus B formula. Okay, now cos 7 pi by 4, which is cos 7 pi by 4 here, root 2 by 2, right? Root 2 by 2, cos 2 pi by 3. Let's go ahead with cos 2 pi by 3. Can you go ahead and substitute? It's just substitution after this, right? Let's go ahead with cos 2 pi by 3. That is equal to minus 1 by 2 plus sine 7 pi by 4. Let's do this like this. Okay, now sine 7 pi by 4 will be equal to cos sine, right? Minus root 2 by 2 sine 2 pi by 3. Sine 2 pi by 3 is cos and sine, right? So root 3 by 2. So what happens here? You're having a denominator of 2, but then minus root 2 by 2. Here what happens? Minus root 6 by 2, right? This is 4, right? This is multiplication. So this is 4, this is 4. So you end up with minus square root of 2 plus square root of 6 divided by 4. Any questions, guys? Akash, did you get that?
Yeah.
Okay, the way I remember these formulas is, see, cos difference identity, meaning cos whatsoever, cos will come with cos and sine only. Sine will be mixed, okay? Because sine is mixed, the sine is going to be exactly the same in sine. Whereas in cos always comes with cos and sine with sine, the sign is always changed. That's how I remember these identities. Let's go ahead and try one more. I'll do a couple more problems and then let you go. Okay, so coming to, I want to do the different double angle identities to at least introduce you to them. Okay, now, okay, double angle identities are like sine 2a will be equal to what? Tan as well, I'm going to give you the formula. Let's see. Now, sine 2a will be equal to 2 sin x cos x. 2 sin x sin 2a, okay, it's 2a cos a. Cos 2a 1 cos 2a will be equal to cos square x minus sin square x. Let me put that. That's the best way to put, and then we'll go ahead with cos square x minus sin square a. However, guys, here you know the Pythagorean identity, right? What is the Pythagorean identity? Cos square a plus sin square a equal to 1. So you can substitute, this is 1, okay, but for cos square a you can plug in 1 minus sin square a. So the formula becomes 1 minus 2 sin square a. Cos 2a can be written as 1 minus 2 sin square a, or the other way of writing it is sin square a, you can write it out as 1 minus cos square a. So if you do that, cos 2a will be equal to cos square a minus, instead of sin square a, you can write 1 minus cos square a. So that becomes 2 cos square a minus 1 will be equal to cos 2a. Does that make sense? Cos double angle formula has 3 different formulas, okay? It depends on what you need where. So here sin 2a is very easy, 2 sin a cos a. Cos 2a, first write this down, cos square a minus sin square a, and then you can plug in the Pythagorean identities to arrive at the other two formulas. Can be either 1 minus 2 sine square a or 2 cos square a plus minus 1. Any questions? Any questions? Okay. Okay. We'll do one last problem on this double angle. Yes. Okay, we'll do one or two one problem on this and I'll let you go, guys, for sure. How about this? See, this is something I want you to do for sure. Let's see. How about this? Can we solve for this one? Can we solve for this one? This is the only problem we'll do on double angles today. See, this requires both actually. So can you substitute the formula for this? 3 cos 2x will be equal to 2 cos square x. How will you solve this? Here, cos 2x has 3 different formulas. How do you choose the formula? The right side has cos square x. So, can I use the cos square x formula only for this one? So, that way, 2 cos square x minus 1 will be equal to 2 cos square x. Now, 6 cos square x minus 3 equal to 2 cos square x. Subtract 2 cos square x on both sides. You will get 4 cos square x will be equal to what, guys? 4 cos square x will be equal to what I am getting. 4 cos square x equal to 3 I am getting. Okay. Now, yeah, ma?
Wait, why did we change it to cos square x minus 1 again?
Because it's a double angle identity, right? Double angle identity has 3 different formulas. What are the 3 different formulas? Cos square x minus sine square x, or 1 minus 2 sine square x, or it can be, see, I am changing the double angle identity to square Pythagorean identities. Make sense?
Yeah.
Now, the last one is 2 cos square x minus 1. Any of these can be used. However, on the right side, I see only cos square x. So, I would want to use only the cos square x terms. When I use that, what this becomes 2 cos square x minus 1. Then I multiply the 3 inside. I get 6 cos square x minus 3 will be equal to 2 cos square x, which then simplifies to 4 cos square x equal to 3. So cos square x equal to 3 by 4. Take square root on both sides. Cos x will be equal to root 3 by 2. Makes sense? Plus or minus root 3 by 2. Right? Where is cos x plus or minus root 3 by 2? Let me go here. Where is cos so can you go ahead use the unit circle to find out where cos x equal to, cos should be equal to plus or minus root 3 by 2. So here, 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 here. So what are the answers? X will be equal to pi by 6, 5 pi by 6, then what? 7 pi by 6 and 11 pi by 6. Makes sense, guys? So, double angle and difference in some identities you will memorize. But we can derive it next week if we all have the time. Okay, it's very easy to derive, but I really want you to understand how it is derived as well. We can do that next week. However, I wanted to touch problems related to double angle and some difference identities. So that's what we did. So can we stop here, guys, or would you like to do one more problem? I am fine either way. You choose. What do you want to do? What do you want to do, guys? You let me know. Anything is okay. If you want to log off and try problems at home, I'm fine. If you want to do one more, I'm fine with that as well. What do you want to do?
Can we do one more?
Yes, absolutely. Okay, how about sine 2x will be equal to cos x. We'll do one more and stop. Sine 2x will be equal to cos x. This is a double angle identity. You see sine 2x is there, but on the right side you have cos x. What is the formula that we can use? You let me know, I'll help you. What can we do?
You could like substitute the sine 2x with 2 sine x plus cos x.
Yes, nice Dhwani. So double angle formula for this can be used. 2 sine x cos x can be used, right? Will be equal to cos x. Here, guys, main thing, this is why I brought this problem up, is please don't cancel like this. You're going to lose solutions. Please don't divide by cos x on both sides. You're going to lose solutions if you do this. That's not the way. Here, go ahead and subtract cos, bring it to the same side. Subtract cos x on both sides. You get 2 sin x cos x minus cos x will be equal to what? Will be equal to 0. From these two terms, you can take cos x common. That gives you 2 sin x minus 1 will be equal to 0. So by the zero product rule, cos x will be equal to 0 or sin x will be equal to 1 by 2. Any questions here, guys? Still here? Do you have any questions here? If they give you, see, okay, here I can as well give you the interval. For this, find out x in the interval this. If I give you this, it becomes easy. Only within the unit circle, you are going to find out where cos x will be equal to 0. Cos x will be equal to 0 or sin x will be equal to half. Where is sin x equal to half? The half is here, half is here. Then where are all the halves? Now, the thing is, cos x will be equal to 0. Okay, first let's write that down. Cos x will be equal to 0 at pi by 2, right? And then 3 pi by 2. Wait, I'll show you one problem about this. Here, there are two values, right? Whereas sin x will be equal to, see, but they are not, see, you have to be very sure what they are asking. They have given the interval here 0 to 2 pi. If they only ask for principal values, you have to restrict it to principal values. Here they are not asking for any principal values. Principal values means sine will be from minus pi by, sine will be on these two quadrants. Cos will be on these two quadrants. Here it is not asked, okay? They are entirely asking for all the values. So cos x is 0 means then x will be equal to pi by 2, 3 pi by 2. Sin x will be equal to half means what are the possible values? Pi by 6 and 5 pi by 6. Makes sense, guys? All the angles in this range are given. Any questions? So for difference sum identities and double angle identities, it's important that you first memorize, do easy problems. I'll give you homework on this as well. So definitely the more problems you solve, the better you will become. Next week we'll see, or I'll move to polar graphs, polar coordinates or vectors based on whatever you guys ask next week. Any questions for me? I'll stop here, guys. I'll let you go. But please work on the homework. Then only it'll be easy. Trig. Okay.
Bye, Priya. Have a nice
Bye,
day.
guys. Bye, guys. Yes, Ma Parvini, tell me.
Oh, I just wanted to tell you that the past couple of weeks, except for last week, we were a little behind school, so like my grades were like dropping a
Down.
little bit.
Uh-huh.
But now I feel like I've catched up and we're ahead of tomorrow, so like.
Amma, do one thing, Ma Parvini. You send me your worksheets as soon as they give.
Okay.
You see, I can match it up, meaning I don't need to cover, meaning some topics I can skip, come back, go back, come back, go back. You see what I mean? The problem is if you don't update me what's going on in school, right? There's no way. Only coming to class, you're updating me. That is hard on me too. You see what I mean? As soon as they give the schedule or the worksheet, send it to me.
Okay.
I'll plan accordingly. You got it?
Yeah. She gives the calendar every time we start like a new unit or new class.
True, right? That time you send it to me. I'll help you, I'm saying. I am more than happy to help out. Okay, you know in Algebra 2 and Geometry, there's one girl who sends it immediately after they get it. So that way, I stitch up my lesson plan to cater to your need because you are the only one who is a little ahead. You got it, huh?
Yeah.
So the others are finding it easy when it comes in school. But if you can send me the worksheet, even the worksheet, Auntie, these are the type of problems we do. Let me know, right? I have my own problems. But instead of that, I'll bring up some of yours. You got it?
Yeah.
Yeah, I don't want your grades to drop. You're going to send that to me as soon as you get it, okay? But see, difference identity, double angle identity, you get a, but let me know if you don't know to do a problem, right? And I have not taught you that. Send me in WhatsApp. I'll help you, I'm saying.
Okay.
You got it?
Yeah.
Exploit the class, ma. You got it? Send me the problem or send as soon as they give the calendar. Auntie, this is what is scheduled for next week. Can you do the same thing in class? Definitely, I'll try to match up. Because you're the only one who is ahead in this class. Okay, the others are all doing less than us. See, now you know, that's why I said mention the class. Next week, I don't know. Frisco SD, sometimes some of the teachers do polar graphs, some of the teachers do vectors. Last year, that happened the same thing. Okay, there was one kid that was doing vectors in school, the others were doing polar graphs. It is going to be a problem. But you can let me know because you're only ahead, right? You let me know. I'll stitch it up accordingly.
Okay.
You get it? Do it this week itself. Next week, I want to know what is that I need to cover. I am okay with anything. I can go to polar graphs or vectors, but both are completely different. You get it? Polar graphs is in your AP Pre-Calc exam, but vectors are not, but they will teach vectors in Frisco ISD. Got it? So if you keep me posted, I'll go with that.
Okay.
Hmm?
Thank you.
Okay, ma. Okay. Bye, ma. Have a good day.
Bye. Thank you.